Hey, we are live. Double check some audio levels really quick. Okay. Hey, thanks for joining me. This is another stream of Code Gets Creative. I'm Andrew, and we do all sorts of creative coding on this channel. Anything from music to visual art to games sometimes. So we're doing another round of Screeps. Just posted in the Discord, so hoping that some people from the Screeps Discord can join us again. Yeah, we're doing Screeps. This is part 3 of automating exploration and expansion. So should be cool. Let me talk through the algorithm really quick, and then we can jump into a private server and we can see what the script is doing so far. So yeah, here's Steam all ready to go, and here's the Screeps docs. Let's jump over to Excalidraw, where we've got some ideas here, right? So the idea here is that we're starting from a homeroom, and this is where we first spawn in. We've got we already start at RCL1 and we're working up from there. That's running pretty well. We're harvesting, we're upgrading, we're building automatically. And so then from there, we want to explore. And as we explore, we want to expand. So the way that the algorithm behaves right now for exploration, we spawn in a creep with the role of explorer. And that explorer is going to build up a data structure just saved in the room's memory called exploration. And that's going to include this graph data structure. Here's what a graph data structure looks like kind of in abstract. There are nodes or vertices, and there are edges. And so when you talk about Screeps rooms as a graph data structure, then basically every room is a node in the graph, and then the exits that allow you to go from one room to another, those are the edges that connect the nodes. So that's cool. What that also means is that if we go from our home room into this next one over, then this has a distance of 1, a distance from the home room of 1, and then if we go one more, then that's a distance of 2, and you can kind of spread out from there. So far, we're able to track all this stuff. Like in previous sessions, we've written the code to build up this data structure, to run the creep through all of these rooms and collect all this data. So that's working really well. I did some other work off the stream to do some work within the rooms themselves. And let me see if I can kind of draw that as well, to kind of get kind of illustrate what that's doing. So let's say that, let's see, we need some colors for energy. There we go. So we've got an energy source over here, energy source over here. And then let's say that the controller is over here somewhere. So we'll pick blue. Cool. So suppose that this is what our room looks like. And if that's the case, we need to pick, actually, let's do one more thing. Let's add some obstacles here, we'll do something like that. What we're basically saying is that there are parts of the room that you can't traverse. Maybe I should put one right in the middle too, just to kind of get that idea across. So I don't know, something like that. So here's what a room looks like, sort of in abstract. What we need to do is we need to decide where to place the spawn, and I'll designate that with this green square. So in order to do that, there are a couple things that we need to consider. It's basically distance from sources, distance from controller, We also need to consider free space away from walls. We care about all this stuff. So basically, we want to minimize these first two things, but then we need to have enough of this other thing that we can like comfortably build a base around the spawn. So that's kind of the idea there. And so yeah, I've got an algorithm written up for that. I think it's not perfect, but like it's really pretty good, and it'll definitely work for right now for this like V1 of exploration. And so basically what it does is it draws a bounding box. This will make sense in just a minute. Let's see. So it draws a bounding box around the sources and the controller, and it says, hey, anything in this area is fair game. And it actually expands it just a little bit. So maybe we can designate that or kind of illustrate that like this. There we go. So we create this bounding box, and we stretch it out just a little bit. We say basically anything inside of here should work. And then what we do is we look at every cell that's in the grid that makes up the room, and we say, what is the distance of this cell from the wall that's next to it? Bring the music down a little bit. So we've got to keep track of like distance of every cell from the walls that it's around. And actually, there's a really good page on the Screeps Plus wiki that I more or less followed that algorithm in order to develop that. And basically, I need to have a minimum distance from the wall of 5. So that lets me build this sort of city block around the spawn. So essentially, I might pick something like this, and that allows me to. It's a diamond, I guess. So it allows me to have this whole area right here that I'm able to build stuff. I'm able to start building extensions around it. And I'm pretty close to the controller, and I'm pretty close to the sources. I've kind of minimized that cost function. So that's the idea there. Okay, cool. So we've got two important pieces kind of fitting together, right? Like we're able to explore rooms, and we're also able to make a decision about like where should I place a spawn. But what we can't do at this point, and we'll write this out like this. We still need to actually like how do we want to say it? Like construct the spawn. And we need to like send creeps to claim and build. So let's put that there. The other thing that we need to do is pick a room. Pick a room to claim. We'll say that. Scoot some stuff over. Yeah, I like this in red. Whatever. I don't think I need that anymore. So yeah, this is our to-do list. You need to pick a room to claim, send creeps to claim and build within that room, and then construct the spawn eventually once that's finished. So I think it might take a couple sessions to have this like fully wired up in an automated way, but I think maybe what we do is we pick one of these and we kind of hard code around like before and after it. But that way we can kind of start to glue this and this together. So I like that. Let me double check one thing really quick. Yeah. Okay. Cool. Yeah, we're back. We got that list of stuff. So with that, let's get our private server fired up. We'll hit play. Play Screeps World. Let this start up. and then you hit private server over here. I'm going to say, yes, start the server at localhost. Here's the server starting up. This is saying allow incoming connections because it's actually a server that's listening for clients, right? That's all running. So now we can just click into this. And here we go. We have connected to our private server. If you're not already familiar with this, we did it on the previous sessions as well, but now we're able to jump right into this kind of managed world where it's easier to make tweaks. And we've got a faster tick rate, which is nice. So here we go. Click into this. You can see we've got our creeps working away. We're harvesting. We're upgrading. Notice how we've got our extensions being automatically planned around our spawn. That's good. At this point, our room is RCL3 and making some progress. So that's cool. But the important thing, and I'll demonstrate this way. In that first debug expansion. No, it's exploration. If I run this, we've got this cool table that tells me all of the rooms that I know about, everything in my data structure, and some facts about it. So notice how, if I run back over to here, everything in the table is a room, right? And you can see things like the distance from the homeroom, right? That's dist. We know the number of sources. We know the type and the owner. So it's like, okay, this one is owned by ADJ555. That's me. These ones are available, meaning like nobody's claimed it, nobody's reserved it, and it actually has a controller that we can claim. Yeah, and then we have last explored. So the next time we spawn an explorer creep, it's going to prioritize whatever has been explored the longest ago. So that's how all that works. Cool. Let's look at that second algorithm though. Let's see, I should have that over here. You'll notice I've got a little bit of, let's make the text bigger by one click. So I've got a little bit of temporary code to like reset exploration. That wipes out the table that you saw here so that we can like rebuild the data structure. But let's see, plan spawn is what we care about. And the thing that I've been running into actually is that my algorithm for planning the spawn is so computationally expensive that sometimes it fills up an entire tick. And so we might actually have to take the time to create, what is it called? Like continuations, where we can do some of the processing in one tick and some of the processing in the next tick. And that'll also make our explorers a little more complicated. But that should be fine. If we end up having to do that, then we can make it work. So let's actually try this and we'll see how it goes. Let's say reset exploration. Okay, it's timed out. Let's say false. You'll see a little bit of the debugging here, just for a split second, of that bounding box, right? So, here's a source, here's a source, here's a controller. So we basically made a box here, and then we stretched it out a little bit. Now note that I manually placed this, our algorithm didn't place it. And so now, based on our algorithm, we know that this is inefficient, right? Because these costs are pretty low, but this cost is pretty high. So it turns out that the new algorithm actually places the suggested spawn point like right around here. And that has a lower cost than this one does. So that's cool. Problem is, I think we've blown up our exploration. Let's just double check. we open up our memory, yeah, 0 rooms, so it just failed to execute altogether. So let's switch back over to here. Oops, save that. So now we should have reset exploration. I'll set that back to false. And now if we debug exploration, this first room is discovered. So that's good. Yeah, I think that means that we've got the first thing that we have to do is actually make this algorithm run over a couple different ticks. So let's dig into that and look at how we do that. So here's the exploration module. You'll notice that we have this function called create room meta. It returns this data structure for every room. So we want to have plan spawn basically be a room position or null. So once we run the entire algorithm, we're going to end up with just a single position as our result, right? It's like right here, this X and Y coordinate. But we need a way to represent like intermediate states. So how are we going to do that? We've got spawn planning over here, and this is kind of a tall algorithm, right? Like we've got close to 300 lines worth of code. I guess this is just visual debugging. But I think we have some kind of logical breaks here. So if we read through plan spawn position, right? That's what we're calling. That's what we were calling from here. Here's the way that works. You basically say, get the controller, get the sources, save that together. So this isn't too much work, right? This is just doing, finding a couple objects in the room. This is not too expensive. This is really just doing a little bit of math. So notice how we got a for loop, for every position, stretch out that bounding box so that it fits. So, we're only doing 3 loops inside of this for loop. And then we expand it a little bit right here. So I think this is a logical break right here. Debug visual, bounding box. Yeah, okay, so this is just debugging for the previous thing. Then what happens is we say distances equals calculate distances from walls, right? This is a heavy computation right here. So I think it makes sense to isolate that. The way that this thing works, you're going to see a lot of nested loops in here. And if anybody knows of a better way to implement this, like a more time efficient way to do this, let me know. I'd be interested. But the way this works is we say distances are a 2-dimensional array. And then we basically say 0 or 1. So if this position is empty, then its distance from a wall starts at 1. If it's not empty, then it means it is a wall. And then what we do is we take each of these cells that have a distance of at least 1, and we grow them gradually over time. And so we're doing that here where we say get the minimum neighbor distance. And then we know that that should be the min neighbor distance plus 1 for this new one. That's what that does. You'll notice we've got this like performed update. So every single time we loop through this, we're like, okay, this iteration, have we performed any updates or not? And eventually we iterate through the entire thing painstakingly. And we've made no updates, in which case we can break out of this while true loop. This is debugging, right? It's a lot of room visuals to show us distances, and then we return back up. Now I'm already noticing, no, that won't work. I was imagining that maybe we could do an optimization here where we say like pass in the bounding box, but that's not going to work because our algorithm relies on growing inward from every single wall, right? So we can't just solve, yeah, we can't just solve it that way. We're basically gonna have to solve the entire room. Okay, but I think like a big chunk of work happens here, and then this happens. So we say there are candidates, and this is basically like iterate over everything in the bounding box, grab the distance. If that distance is greater than or equal to the min distance required, which basically is like free space away from walls, right? If that criteria is met, then this is a candidate. So we create a candidate position, and then we do some very expensive work right here, where notice how we say for every important position, right, those three things, the source, and controller, do a pathfinder.search from the candidate position to that other position. Take its cost, and then we're summing all of those together. And so, you know, our candidate is an X and Y position and the cost of that position. Here's the debug for that. And then boom, we put it right here. So then it gets pretty, like, I think everything afterwards is pretty straightforward. You basically say like, okay, the best candidate is just the candidate with the minimum cost. So this is just reducing to take the minimum. We debug it so we can see like where we've chosen, and then we return it. And we wrap it in an actual room position. So that's how all that works. We just need to break it up is all. So what that means is like we need a way to store the result of these computations. So let's come up with an interface that lets us do that. So we might say something like spawn planning computation. And then we could say something like status. And we can have, you know, type planning status. And this planning status could be like not started, or is it really just two things? Because like this is pretty cheap, and this is pretty cheap. We're gonna run this a couple times. So maybe like calculated distances. Or candidates. We could like find each of the candidates. That's pretty trivial though. I think it's like getting the cost of each candidate. I'm going to assume that this is pretty cheap. Like we're just iterating over an array with a handful of elements. It's going to be like 10. So I think that's fine. So I think that's it. It's basically like finished. We've got that. So then I think we say, oh, maybe what that actually means, maybe we should do it this way. I'm basically doing a union type of everything. We're going to change this to status. And then we'll say distances, and you know, and something's going to go in there. And then I think we can say bounding box, and that is type bounding box. No, I think the bounding box is probably cheap enough that we can just do it twice. So let's let's maybe just do that. And so then finished. Do we save everything? I don't think we need to. I think it's like chosen candidate. Or maybe it's just like X, Y, cost. And just leave it at that. Yeah, I like this because this like locks us into types where we're not going to have like unrepresentable states. Distance is of type number bracket, like two-dimensional number array. So that's that. Okay, and now here's an idea. What if we basically say export function plan spawn position. I'm going to export this. Format it a bit. Yeah, and this is going to take in a room, but it's also going to take in computation. And I think we can default it to null. Well, or actually, we default it to status not started. Yeah, and we. So let me comment this out for a minute. It's a very tall function. Let's alias this just to kind of by this. And this is, so what this is going to do is it's going to return another spawn planning computation. Yeah. Okay. And let's see, let's move this out here. So now we're going to say plan spawn, and I actually want one status skip, something like that. The reason I care about that is like I want a pass through where I just ignore it entirely. So now we have a spawn planning computation right here. And so then down here, we can say, if it's an unexplored room meta, we don't care about it. We can say status skip. And then right here, we can plan the spawn position. Okay, cool. And so now right here, we basically have a switch on the computation.status. So we've added status to every one of these, and so we can do a switch on it. That's great. It lets us do kind of a simple pattern match. So we can say if it's skipped, then just return that very same computation, do no work at all. If it's not started, then we can say calculate, let's see, I'll say like compute distances, something like that. And we'll define that in a minute. And then we'll say calculated distances. We will return the result of some function called, what should it be? Like select candidate. Maybe like compute best candidate. There we go. And then if it is finished, this is another similar case. We just return the computation, do nothing. So now right here, we fill in the blanks. And this is going to return a computation. And then this one is going to take in those and also return a computation. Yeah, and that should do the work that we needed to do. So notice how what we're essentially doing is we're taking all the work right here, we're just splicing it apart into these helper functions, and it'll do the work there. That's real cool. Let's uncomment this so that we can see it a little better. And whoops, let's start by extracting this compute distances. So that's everything down to here. Paste that into there. Oh, cool. So, okay. You'll notice we have an early return here. What this essentially means is that, like, there is no result. Like that, we're not going to end up with a candidate. So we might actually, I'm trying to decide if we want a whole nother status for that. Yes, I would like that. I think we can use skip though. That'll be great. So we're gonna say status skip. Oops, skip. Cool. And then if we get all the way down to here, then we can return status is calculated distances, and then pass in the distances. Cool. Now let's see, what do we use the, we don't even use the bounding box for this part. Oh, hey. Okay, well, so that's cool. Some of this actually belongs down here then. Let's see. What is this complaining about now? Oh, yeah. Let's just like underscore it so it's not named the same thing. So I think compute distances is fully implemented now. We need to compute best candidate now. So let's grab this, pull it out of here, move it into here. And let's see. So I'm actually going to duplicate this. And then I'm going to cut and paste all of this. Reformat it a bit. And let's see, what is this complaining about? Oh, I see. So this should be unreachable. I guess this is fine. Like, it's redundant, but it makes the intent clear. So I like that. The other thing that I think we should do if we have not already calculated distances, we're going to throw a new error. Distances have not been calculated yet. And this is a bit of defensive programming that we don't think we're ever going to hit. But what it does is it tells the TypeScript compiler that, hey, if you manage to get below this line, we know for a fact that the computation status is actually calculated distances. So we know that distances exists. So we can pass that in there. Everything there. Create our candidates. Find the best candidate. Yeah, okay. And then right here, we need to say status is finished. X is best candidate.x. Y is best candidate.y. Cost is best candidate.cost. Whoops. Yeah, that's the thing. Cool. And then we delete that. That was our leftover shell. Yeah, and I think we've fully rewritten this so that so we can do it piece by piece. This is kind of getting in the way. What is the debug thing? Go ahead and move this in here. Min good distance I renamed. There we go. Now I could imagine having to like calculate distances from walls. Maybe that in and of itself could be too expensive as we get later into the game and we've got multiple homerooms. I don't think it's a problem yet. Like I was able to debug this just fine. Like I was able to run it just over and over and over. It's really once you put the pieces together that it stops. Like we're not able to do it in a single tick. I think we're good for now. Let's make that optimization later. Let's see. We've got this. So we've got all the logic in place for incrementally computing, but we need something external to it to actually drive that computation. So we can do that out here in exploration, I think. Actually, probably in the rooms. Let's see, when we create the room meta, we do this, but then need to be able to say, how are we ever going to finish it? Let's see. What if we... I mean, we've got this, like, record room exploration time, which is a thing. That's over here? Yeah. Wait, no, where is that actually? Yeah, so I think this is the right place to actually put this. So let's actually say... we're going to say something like update room exploration. And we're going to rename that, and we're going to put it in here. And I believe this one actually calls it as well. Yep. And check out this to-do right here. To-do, update facts about the room 2. So let's see what this does. We get the exploration. We find the room meta for this room. And then we update last explored. And I think we need to say, let's see, if we haven't finished computing if we haven't finished computing the spawn planning yet, then iterate on it, something like that. And then, and we might actually want to, like right here, you might want to say only run this every 10 ticks, question mark. I think we want to run it like, I think we want to run it for sure for every explored room, so then that starts to get kind of special casey. I'm not sure if we really want to do that. I don't know. Cool. Let's see, from Sil10. Hi, what's your high-level strategy for rating the rooms? Ah, cool. Yeah, good question. Let me show you. I'll run back over to here. And I'll talk about what I'm doing to like place the spawn in the room, which isn't exactly what you're asking, but I think it's going to tie into this. So in order to choose a spawn location, the way my algorithm works is I'm looking at the distance from the sources, right? So here are 2 sources. Distance from the controller, here's my controller, and then free space away from the walls. I need to have enough room to build this like diagonal city block. You can see an example of that here. So I need to be able to do all those things. But essentially, I want to minimize this cost, right? So if I put this way up here, then this cost is low, this cost is fairly low, but this cost is quite high. And so currently I'm calculating that cost just by adding the pathfinder.search cost. So you know, there's some cost associated with like starting here and moving here and moving here and eventually getting here. And you know, maybe I'm forced to move through swamp or whatever, and it'll tell me that. So you know, I'm looking at each of these cells in order to decide like what's the cell that gives me the lowest cost, and then I choose to, like, I plan the spawn in that location. But now in answer to your question, your high level strategy for rating the rooms, like rating the rooms against each other, essentially we can take this cost of like, according to our algorithm, this is the very best place to put a spawn in this room. But then what we can do is we can say like, hey, in this room, we're going to place it here, and here we're going to place it here, and here we're going to place it here, whatever. But we have the costs saved for each of these as well. And so then what we can do is we can zoom out and look at our exploration for every room, and we can say, like, it's only worth our resources in the homeroom to pick a single room and like really invest in that room and like pump everything into there. And so let's pick whatever room is going to succeed the most, right? And so I think that cost number should be part of that. You might notice right off the bat there's a flaw with that, which is that, like, if I've got two sources, I'm going to have more or less like 50% more cost, right? Than if there was just one source. So that could be a problem. I could potentially solve that by like dividing by the number of important points. So, you know, here's 3 important points, divide by 3. That gives me like the average cost to do stuff. But I think there's also this, like, I probably only want to move into a room that has 2 sources anyway, likely. So maybe instead of coming up with like a single quantitative score, yeah, personally I avoid single source rooms now. Yeah, I would agree. It might be cool to like kind of colonize them and just treat them like remotes. So you go out and like harvest from them and bring them back. Maybe that's worth our time, but like building a spawn there is not worth our time or resources. So I think we don't necessarily need to roll all of this up into a single quantitative score. But I think if we've basically got some criteria that we can filter on, then at that point, that cost number is something we can just sort on. So it's like filter and then sort, and then whatever is the top, that's the room that we choose. Yeah. In fact, let's write that down. Filter to available rooms with 2 sources, and then sort by cost. Choose the first room. Yeah, I think that's our algorithm. And I think we need to add to our to-do list from kind of catching up today. So we need to like compute cost in each room, or no, really it's like plan spawn in each room and record costs. I might not be at this point yet, but I also added unique mineral to my room rating eventually. Oh, cool. Yeah, I like that. I would say I'm still like early to mid game. I don't know what, how you constitute like mid game versus late game, but yeah, I haven't done anything with mineral harvesting yet. So I think eventually I should add that, but I'm not ready to do that just yet. Good call. Cool. Yeah, thanks for the feedback. Super appreciate it. So let's see. We run back over to here. If we haven't finished computing the spawn. So yeah, I think it's not gonna hurt to do this every tick. If we're in an explored room, I totally don't mind just like iterating on this. So let's do that for now, and we can like kind of keep an eye on CPU usage post heavy computation and see if this is a problem. But let's see. we basically want to say room meta dot plan spawn. Oh, hey. You know what we really want to do? We actually want to just break early here. If there's not a room meta here for some reason, just return, do nothing. Hey, Dollar Akshay, welcome. Good to have you with us. I remember you from a time or two ago. Yeah, thanks for coming back. Let's see. So at this point, like, we know we have a room meta, right? We're returning early if that's there. Oh, cool, Marvin, you're still here. Yeah, welcome again, Marvin. I remember you from a couple streams ago. Good to have you with us as well. Let's see. So we update the last explored. So now we can say the plan spawn, and this is actually our computation, right, that we can pass into here. And we should actually be able to just say plan spawn position and then pass in room and then the plan spawn. Oh, doesn't like this. Okay. Yeah, hold on. So notice TypeScript is helping us here, right? So I want to pass in a full room here, and we need a full room. We need visibility, more specifically, so that we can compute distances. And that's because if we scroll down into here, notice how we're calling room.terrain. Oh, hold on. Hold on, even if you have no access to it. Oh, just kidding. Let's double check this. Yeah, everybody's like panicking. We've got a TypeScript error alert. Okay, cool. So let's actually go back through here, because I think it's possible that we either we genuinely need a room, and like we're just gonna have to like call this at different times so that we reliably have a full room with visibility. Or maybe we can get away without it, and we can simplify all of this down and just pass in like the room name. So it looks like best candidate relies on it. Let's see, room.controller. So does anybody know? Yeah, exactly, folks. Like room.terrain does not require. Yeah, I hovered over it very quickly. I don't know if you saw, but in very small text, it says this method works for any room in the world, even if you have no access to it. That's cool. Yeah, notice how this only needs the room name. So since this is just a helper, let's go ahead and simplify this down to begin with. And then here's where we call it room.name. So then distances, let's simplify that down as well. Room name. Oh yeah, hold on. Got all excited. Room.name. Let's see here. And just use the constructor. Yeah, totally. So let's see. The next thing we got to figure out is, can we get the constructor without the name? Let's see, room terrain constructor. So let's run over to our docs. I don't think this is actually going to work. Where is room? Can anybody tell me off the bat, like, is there a way to just call the room constructor and create a room? Like, get a reference to it. The reason this matters is, like, if we don't have visibility into the room, then we can't do these computations. Raider Blitz says nope, only terrain. Okay, cool. So we have to be able to do this work. We also, so we need it here once again. Yeah, we need it for this. I also assume. So notice how we're also calling pathfinder.search here. So pathfinder.search, I assume that like this doesn't need visibility of everything, but some of this other stuff does. I normally do this when a scout is in the room. Yeah, exactly. Like, yeah, I guess you're right. I'm going back and forth about how I'm talking about this. So I will have a scout in the room. I happen to call them explorers, but like explorer, scout, it's the same thing. Let's see. I don't think realistically we're going to do this computation on a room that we don't have visibility for. Basically, like, we're going to go into the room, do the computation over the next 1 or 2 ticks, and then we'll leave. So we do need to make sure to not like come in and then leave in a single tick, because we won't finish the computation. But I think my explorer already kind of handles that, so I'm not too worried about that. So I think given that, let's go look at update room exploration. Here's where we call it, and notice how, yeah, we already have a room here. And then homeroom, here's where we call it. So yeah, this should be good. So room is now a room. And then let's see, we've changed some things. Notice how we're shadowing now at this point, so we got to rename some stuff. So just to clarify types, we're doing that. Okay, and now at this point, plan spawn position, we're calling it with the right types. So that should work great. The other thing that you'll notice is plan spawn position. This is written in a way that like we can call it all the time, and if we have skipped it, we'll just return the same thing and do no work. If we're finished, we'll return the same thing and do no work. So this is a pretty cheap operation. In fact, if we want to get a little more clever, we can like do this. It's going to be like pretty negligible, but like, I don't know, we got that there. And I mean, whatever, we could even put that there. It's like the very first thing we check. Okay, so that should run now. I think we're ready to try this out. So let's see how this does. What are we doing here? Okay, cool. I think we're in a bad state because we've made changes to the data structure, but we still have it in our memory. So this is why I wrote this janky code to say just like blow away the data structure. Oh, hey. Okay, so what we're seeing here, hey, stop. Oh, okay. So this is interesting. This means that even just doing our fraction of work here is turning into a problem. Let's comment this out. So now we're back into a working state. Come on. Okay, everything is calm again. I don't have a great way to do this. But we could basically like we'll do like 750. Let's see how close we are. Let's bump it a little closer. I don't know. Okay, we're just about there. And boom. Should run. Yeah, I know, it's janky, but it did the thing. So, okay, we reset exploration, and then you saw this kind of flash of room visual stuff. So at this point, it should have run. Let's see, hit refresh on this. If this was like, I don't know, I was willing to do something that janky because I think we're only going to do it this once. So we go into here, plan spawn. Oh, look at this. So we have calculated distances, and we've got this like monstrosity. We've stored our thing. Oh, but it's right here. So I'm gonna add this back in. I'm gonna add some console logs to make this clear. Compute distances. And then right here, we're gonna say compute best candidate. So let's save this. This code should execute, right? Because this is gonna happen every tick. So we should see this log, and then when we go back into the memory, we should see a candidate chosen. Save that, come back over to here. Oh, and look at that, the script execution timed out. You'll notice that we've got like, yeah, it's it's kind of random, like how much of this we calculate. Okay, cool. But what that means is that like computing the distances is fine. Like we're able to keep up with that. Yeah, there's some progress. Like we're basically like doing part of the work, and then we run out of time in the tick and it gets cut off. Okay. So let's dig into compute best candidate and see. Break it up more. That's what we're gonna do. So yeah, let's look at what's cheap and what's expensive. Controller position is cheap. Source positions are cheap. I mean, we could go ahead and break it here though. Like it wouldn't be too hard to do that, and it is kind of a natural break. But notice this bad boy. Like, I think this is our problem. Like, notice how we're iterating, notice the iterating over y, iterating over x. So we're basically saying like, crunch through a whole bunch of options in here in the grid. And then for each of those grid cells within the bounding box, we are going to call pathfinder.search 3 times for every one of those cells. So very expensive. That's that. Yeah, that looks troublesome. Well said. So now we've got to figure out what is a good way to bail out on this in a way that we can like safely resume from it, where we know the state of the computation so far. Let's also do this. We're gonna say calculated important points, or maybe like calculated, I don't know, calculated basics. And so this is going to include, let's say, the controller position. And it's going to include source. Let's just say like controller and sources. Room position bracket bracket. And then notice how this is going to copy through. Do we care about the bounding box? Yeah, like this is starting to get kind of long. Like we're rebuilding a data structure with a lot of stuff. However, and I'm curious if anybody in here has done work with a library called Redux. So Redux is a JavaScript library that's usually used along with like React to make like front-end UIs for web apps. And Redux is all built around this idea that you can update the state of your app with by using reduce. So if you're familiar with like array.prototype.reduce, Redux relies on that. And it gives you some cool guarantees, like your app state is immutable. So you're not kind of making edits from all sorts of different sources. You know that you're always calling the reducer in a specific way in order to make changes. And so we're following a similar pattern here where we have sort of a monadic structure. I don't know if it's fair to call it that. I'd have a monoid. I think it's a monoid, but not a monad in this case. I'm not super strong on that part of the theory. Basically, like we've got this immutable data structure and we can pass it through this function and we'll always get one of these back and there are no side effects. And so that gives us some nice guarantees. It's a cool paradigm that you can do programming of like kind of the core of some algorithms. But you'll notice that one of the painful things is we are having to kind of rebuild some things, right? So that's what's going on here. Good news is it is shallow copies, so it's a pretty cheap operation to do. You're basically just like moving a reference over to a different container. And so in terms of like the work that's being done, or in terms of like bytes that are being copied across your computer's memory, it's pretty trivial. And so yeah, you get a lot of really cool benefits from doing it this way. So we've got these. I think I do want the bounding box too. So at this point, I'm ready to create, let's maybe call it like the room context. So I feel like that's making more sense now. So context is of type room context. And now we can grab this whole thing and move it into here. You see how like, it's not super different, but it's made the intent a little more clear. It's easier to read the API. So I like that update. But now it's also easier to grow the context and do a little bit more work in order to build the context. So I can say bounding box, and that is of type bounding box. So now, if we have not started, let's say compute context. And then if we have calculated the context, oh hey, one thing I just noticed is that I'm not being consistent about computed and calculated. So let's get consistent about that. Computed, there we go. Okay, so if we're not started, we're going to compute the context. There we go. That moment when the CPU errors spam each tick. We've all been there. Yep. Here we are. So let's see, we're going to compute the context. So here's where I need this. Let's see, we're gonna have to tear up a few things, so pardon the squiggles. Let's see. We need to have a guarantee here. That we have already computed the context. Okay. Let's see. Less Pathfinder. Yeah, maybe there's a way to approximate what that was doing. Yeah, I think that's a good point. What we're doing there, right, is we're saying, like, you know, suppose that this is our, here, I'll put down a flag just to kind of illustrate what we're talking about. So let's say that we're talking about this location. We want to find the distance. Oh my gosh, I forgot that was a thing. Did you all see that? Woo! Yikes. I think we just spawned a builder. We're gonna build a whole lot of roads. Yay. Let's see. I don't want to go in and remove every single one of those. So let's say room.first.find construction sites. Let's make sure that's, yep. That's funny. Oh, come on. Everybody should be laughing at me in the chat right now. I'll bet you've all been here though, let's be real. All right, boom, they're all gone. Okay. What I wanted to say was, and now I'm like not sure which of these colors I've already done. Like that was some code that I written like 3 years ago to put down a stamp. Yeah, so I actually do have global commands. I've got a really cool set of them. Yeah, here they are right here. There's stuff for spawning, there's stuff for debugging, etc. Yeah, flags happen to be a nice way to like visually do that as well. but I mean, obviously I just forgot my API for that flag, so that's a heavy downside to that. Okay, so let's talk about Pathfinder, right? Because Pathfinder is just really expensive. So yeah, just finding the closest open space near the controller would be best, since controller is preferred. So I think there is still like a trade-off here, right? There's like distance from controller, but there's also distance from source. And it's not just distances in like Manhattan distance, right? So, you know, if I built something right here, well, no, I don't know, like, basically I might have to like run around this obstacle here. Or maybe there's like swamp this direction, but there's not swamp this direction. That's the thing that I'm worried about. And so if I want to get the exact cost number, the only way to do that is with Pathfinder. But it's super expensive. So yeah, I mean, like, is it good enough if we do just Manhattan distance? Yeah, what are everybody's thoughts? Like, is there a decent compromise where we can still get some kind of decent like distance type stuff, but we're still not doing all that heavy work? Let's see. I don't believe distance from source is nearly as important, but if you do want to do that, then there is a better way than Pathfinder. I suggest distance transform and find closest by range. So, are you trying to build roads toward the source? No. So, yeah, $Akshay, I'm actually trying to choose a location for a spawn. So, let's say that I'm exploring rooms, and I'm in some room that I don't own yet, right? So notice how we've got a source here, controller here. It probably makes sense to put the spawn like somewhere in this bounding box. But like where exactly? And so my criteria for placing that is basically, and here's kind of a mock-up, like a whiteboard diagram. Basically, I care about these things. So I want to minimize distance from sources, minimize distance from controller, and then I need to have some minimum, let's say minimum free space away from walls. And I want to do that because I know that there's going to be this city block concept where I want to have some roads, I want to have a, what's it called? I want to have towers, I want to have storage, like all that kind of stuff. Damn, dude, love your mock-ups. Thanks, appreciate it. Yeah, this is, I'm a huge believer in this kind of stuff. Like, a lot of people just kind of jump into like just typing code. But if we're thinking at this higher level first, it helps us to kind of zoom out and like think more about the algorithm so that we can come up with a better algorithm, hopefully. Okay. So yeah, Marvin, you mentioned a couple things that I want to go back over. I don't believe distance from source is nearly as important, right, as distance from controller. So I think that's interesting. Like, my impression is that early game, it's like super important. Like, that's your bottleneck essentially, and you want to mine it out as aggressively as you can. And like your distance between the sources and the controller really affects like your early game ability to upgrade. And so, I mean, if this is our algorithm where we're measuring this distance and this distance and this distance, then that's also a really good proxy for like, how long is it going to take to do like a total round trip from a source to a controller? So like, what are your thoughts on that? So let's see, distance transform closest. Here's how I find my bunker position. It runs distance transform, outputting positions that are open enough for bunkers. I use find closest by range to find the closest position to controller. You want source 2? That works fine. Yeah, okay, cool. So it's basically a matter of like, you know, which what are we valuing in that? So, cool. By range, I mean get range to. Okay, cool. Yeah, let's pull that up in the docs really quick. In the meantime, oh shoot, I just opened this in the wrong window. Let me go back. Sorry, I just blew up my Twitch chat, so I cannot see whatever y'all are saying right now. All right, we're gonna take a minute and check out some code that Marvin TMB posted. Thank you. The International Screeps bot. Very cool. Let's see, how tall is this? Get that. Let's see. You build a cost matrix. You do a distance transform on open spaces. So let's go look at those. Okay, so you didn't write the distance transform algorithm. I was gonna say, like, this feels like some of my computational mathematics buddies from school, where like they didn't believe in multi-letter variable names, but like, no worries. It's not their doing, right? Okay, cool. We find some open spaces. Oh, cool. I like how you're doing this. So you basically like create a one-dimensional array for every cell, and uint8 arrays are really fast to index into and stuff. Yeah, honestly, I should eventually I should switch my distances to use that as well. Open spaces. Yep, I've got a function very similar to this. Display cost matrix. Let's see. Yeah, you've got some like room visuals right here. Sweet. Okay, and then find closest by range to these anchor points. So you select some anchor points, right? Anchor points, plural. Let's see, how do you... Oh, yeah, it's right here. So you add an anchor point every time this is true. Value is greater than 6. So this is a magic number, but I guess this is basically like you need this much free space in order to fit an anchor, right? So, okay, cool. And then here is get range to, and in this case you care about exits. Oh, and get range to, let me pull this up in the docs really quick, but get range to, yeah, oh, okay, so this is, notice how this is a room position method. I work in too many languages at work, and so I get mixed up between like function and method and procedure and okay, so get range to is a thing, and it gets the linear range. Yeah, gotcha. And then you say find closest by range. Find closest by range. Oh, hey. And let's see, that's right here. Find closest by range. Oh, hey, and actually check this out. The jump point search algorithm and Dijkstra's algorithm. High CPU cost, sure. Okay, I think there are a couple of interesting options that I think we just bumped into here in the docs. But let's see, let's catch up here. If you can harvest more than 5 energy per tick at the start, which you should be able to, then source distance means only a few hundred more energy per creep lifetime in hauler and harvester cost and lost energy. That is really interesting. Okay. That is really cool. I feel like I haven't fully internalized that yet. I need to keep Sorry, I said that all wrong. Okay, please. Oh, 10 energy per source. Okay. So 10. You have to be a little further on in the game in order for that to start to matter. Okay. I feel like for early game, since I'm still very interested in kind of early game performance. Like I would rather kind of optimize around that and like but I mean that's a really good point that like eventually you get into this kind of mid game where you've got a lot stored up in a storage and going from there to your controller matters. But I guess relatively soon after that, you go to links and like you just like beam over to it. I don't know. This is accounting for early game. All right. You just have to be able to mine 10 energy per source. You're talking about like 10 energy per source per tick, right? So you throw a bunch of harvesters on at the same time, or have like a really beefy harvester, which you need a bunch of extensions for. Essentially, you need 3 2-work part creeps per source, which isn't crazy. Okay. Yeah. Okay. I think you're convincing me. So, or 3 2. Right. Just that's how the math shakes out. So that's cool. And use creep.pull, make a pickup truck to get them there. Wow. Okay. Do you use your haulers to pull your harvesters into position then? Pretty wild. So yeah, I think. What else did everybody say? Yeah, Dollar said by range I mean get range 2. Yeah, so we've. Where did that go? Get range 2. Here's that. Sweet. I think Screeps is about approximation first, polish later. Yeah, I mean, honestly, till 10, like that's, I believe that too. I would just use get range 2 for a first pass or basic distance. Yeah, honestly, like, I think, I think let's maybe just do that for now, and that'll give us a pretty good number. I would say RCL less than 1, just use work. Yeah, work, move, carry. Yeah, you bet. And then once you get to RCL 2, use work times 5 and move. Oh, that's sweet. So it takes them a while to get there, but like once they're there, they're very efficient. Yeah, I like that. I think I want to go make that change. Like that way I don't have to stress too much about coordinating between multiple creeps. Yeah, like we're trading off complexity. You know, like it's a lot easier to ship that if we just have like work times 5 and then move. So that like incrementally, that's a really cool improvement. Okay, speaking of incremental improvements, let's get back to the code. But seriously, thanks everybody for all the feedback. Like this is really cool. Okay, so let's keep crunching through this. I think once we rip out all of this Pathfinder search stuff, who knows? Maybe we won't even need to do this incremental computation at all, but we'll see. So let's grab source positions here. And I'm going to delete. Well, let's see. Let's just copy for now. I don't want to like rip the code apart so much that I can't follow it. So we've got that. And then we need to calculate a bounding box. Where do we do that work? So I'm going to grab this. And then we will say, let's see. So we're grabbing all of our important positions. We're creating and expanding our bounding box. And then if we happen to have debugging on, we'll render it here. So then at this point, we've done all the work that we need to do. So this is computed context. And so then the context, and let's maybe build that here. So context needs to be controller, and this is controller dot, yeah, it's just controller position. Yeah, and then sources is source positions. And then, oh, we also need to save bounding box. Okay, cool. So we now have a full context built up. Let's go back up to here, right? So if we've not started, we're going to compute the context. If we have computed the context, we will compute distances. And distances, we don't even care about context really, but we're just forcing this to be linear. What we do need to do though is say context computation.context. Now, y'all remember before we were talking about Redux and talking about immutable data structures. So this operation right here is really cheap. We already have computation in memory, and we already have context in memory. And so just creating another pointer or another reference to that same data structure is really cheap. And eventually this is going to get serialized into the Screeps memory. But we have to do that work anyway, right? Whether we're mutating it or whether we're treating this as an immutable data structure. And so we're feeling basically no performance hit from this, but it's a lot easier to reason about our code. So cool strategy here. Okay, so now we've computed distances. That's great. Now we're ready to compute the best candidate. So let's see. Don't need to do this. We don't need to do this or this. I think we still need important positions, don't we? We need it right there. Remember that this will change, but like everything around it is going to stay the same. So let's see. At this point, we know we have that. We should be able to say context comes from computation, and we should be able to destructure that further to say controller, and then sources is source positions, and then bounding box. Yeah, check that out. Is oh, we're redeclaring it. Right. So then we delete that, and delete this. Okay, and then what's our problem here? iRoom position isn't assignable to that. That's kind of funny. Okay, so let's see, what do we need to do? Let's maybe let's extract this out. So I'm going to say calculate cell cost. Yeah, something like that. Or no, this should be candidate. Calculate candidate cost. So this is the candidate position. And then let's actually be explicit about like, here's the controller position, and then source or let's just say, let's see, controller is that, sources is iRoom position array, and then this should return a number. Now, notice what this is kind of helping us do. Oh, and hey, this needs a type as well. But what this is doing is it makes it easy to kind of extract this, but then tinker with it later, right? So Marvin makes a really good point that like maybe eventually when our script gets more sophisticated, we're gonna care about this cost in a different way. Like we're actually gonna apply more weight to the cost of traveling to the controller and less cost to traveling to the sources. But right now we have kind of a different weighting, right? So what we're doing is we're just extracting that. So we're gonna say cost equals calc candidate cost, and we're gonna pass in that, pass in that, pass in that. And so we can pull that out, and essentially we've just extracted this, right? We just did a short refactor. And then what is important? Positions. Right, controller, sources, we're renaming some stuff. And then eventually we will return cost. Okay, sweet, we're getting really close. Figuring out the weights of the room cost parameters. I did a mini study on my rooms for that. Haha. Awesome. I'm curious to know like what was your mini study? Like how did you go about making that decision? Like what data did you already have stored? You know, what sort of analysis did you do? Like that would be really interesting to hear. Range 2. Yeah, I think so that'll give us a range to each of those important positions, and then we reduce over those mini costs, right, so that we can get the total cost. Cool. All right, let's see. I ran multiple rooms up to RCL 5, saw how fast they progressed based on the parameters, something like 20 room runs. And then I recruited my statistician friend. I like the ending of that story. That's very fun. Cool. So does that mean that you had like 20 rooms and then you like ran those same identical rooms with different weights? Does that make sense? Like in order to have a controlled study, you need to, like, you've got to keep everything else equal, right? Like you want to isolate the variable of your weighting algorithm. So it seems like in order to do that, you would need to have like 20 rooms that all look a little bit differently, run it with one weight and get, you know, kind of the performance of that. But then you need to reset the entire thing and like run the exact same 20 rooms with a different weighting. So it, is that the way that you were thinking about it, or is that the way that you did it? 20 different layouts, but same progression. So is that like 20 different layouts, 20 different weights? I don't know if I'm connecting like the parameters of your experiment, I guess. And in the meantime, I think this is ready to go. No way, its parameters being things like source distance, openness, controller distance. Okay, I think I understand. It's basically like you had 20 different rooms and kind of 20 different opportunities to like tweak different things. And then you like measured it all. Or maybe it's like you placed a spawn in each of those rooms and like measured its performance, and then retroactively you were like, it seems like these things happen to apply, like source distance and controller distance and openness. Yeah, okay. Yes, got it. Okay. Cool, cool. Yeah, thanks for walking through that. That is really cool. So, Dollar, it sounds like you got to do that next, man. Like, I don't know why you're not calling up your statistician friends to like collab on this. But no, that's way cool. 10, I like that a lot. Okay, I think we're ready to try this. So let's save this. Oh, I do want to make sure that we have like logs on absolutely everything. So that we can really clearly see the work that we're iterating through. Distances, compute best candidate. Okay, so I think we've got finished, right? Yeah, that's way down there. Okay, cool. So that's all there. We save that. All right, let's go back to our homeroom. See how everybody's doing. Cool. And now, let's you know what? We're gonna be good citizens. You remember how we had to like jankily apply this? Let's actually take the time to create a command for this. So let's see. Room prototype. So we'll create a function. And let's see, we're lifting everything up out of here. We're only ever going to run this on the homeroom. So then we need to say, if not this.memory.roll home. And actually, I think, yeah, I've already got this. We'll say resetting exploration. We'll reset it there. Create room meta from the room to the room. We just need to import that. Oh, and then this should be this, comma, this. We put it into there. Okay, now notice the squiggly here. This is actually the Screeps types for TypeScript that are getting after us. So it is true that if you look in the Screeps docs, there is not a property reset exploration on type room, right? Like if we come over to here, there's nothing in here about reset exploration. So that's totally true. So the way that we handle this is we need to tell the type system that actually we have extended it. And so we can do that right here. And Marvin, you better be watching. Look, I'm doing this for you. Just kidding. I'm doing this for my own sanity as much as anybody else. So this is there. Notice how the squigglies have gone away now. So we've said there's an interface called room, and it is declared on global. Basically, the the ambient types that Screeps has injected are being overwritten here. So that's how that works. Yeah, it's neat. I haven't used prototypes much. Yeah, so this is like room.prototype already exists in your bot. Like whenever you call these methods, if you've got a variable called room and you say room.find, then you're actually executing a function that is attached to the prototype of room. That's how that works. And that's actually a quirk about how the JavaScript language does classes. So it's a little bit different from kind of like if you're maybe familiar with Java or C# or some of those other kind of like textbook style object-oriented programming languages, their model of inheritance is really cut and dried. Whereas in JavaScript, this concept of prototype works just a little bit different. And you can actually have something called a prototype chain, where you can have multiple classes that inherit the prototype of one another, which is similar to inheritance, but it's a little bit different. It's really interesting. But the other really interesting thing about this is that you can take code that's written by somebody totally different, right? Like I didn't write the source code to Screeps, but I can go in and extend the functionality of that third-party code. And sometimes you'll hear this called monkey patching. I'm monkey patching the Screeps code. This should still be done sparingly. If you do this at work, your coworkers will ask you, like, are you sure that you should be doing this right here? So be cautious about this. But there are definitely some like appropriate places to use this. So it's a really cool tool in your tool belt. Yes, monkey patching. I think I've heard other people use the phrase monkey patching to describe kind of like hacky bug fixes. I think I've heard them call that monkey patching as well. But yeah, like the way I was taught, like monkey patching basically means like you're injecting your functionality into other people's code. They're actually, so since we're on the subject, and since I am a Rust programming language evangelist, now we need to go look up what's called Rust traits, which is super cool. So in the Rust programming language, there's this concept of traits, which is sort of like, it's sort of like interfaces in Java. But what it lets you do, so you can define a trait called summary, which means like any struct that implements this trait has to have this function that like follows these rules. And so notice how like here's a struct called news article, and it's got these properties on it. But then notice how there's this block here that says impl summary for news article. So news article is my code, but it also happens to implement somebody else's trait, right? And so here's its particular implementation of the summarize function. And so the way that traits behave in Rust are a lot more first class. And they do it in a way that the compiler actually protects you from doing it the wrong way. So there are things that you can do with monkey patching in JavaScript that are like kind of risky, and you might get it wrong. And so languages like Rust have this as like a kind of a dedicated concept where like trait is like part of the language itself. You know what I mean? And so if I go in and I implement summarize, but I like return a different type, then my code is not going to compile. The compiler is actually going to protect me from making that type of mistake. And you can lean on the compiler for that type of thing. So super cool stuff. Yeah, everybody go learn the Rust programming language. It's my favorite. Back to Screeps. Okay, we've got our command, and TypeScript is cool with our command now, right? So that should work. We also need to go back to here. Actually, we're not ready to do this just yet because we'll be in a bad state. So let's actually call this right now. So I've reset the exploration, good. And notice how we have computed the context. So we know that gets run because the first computation is always going to happen on that exploration tick. So let's just add this in, and it should just run itself now. So we go back over to here, compute distances, compute best candidate, and we're done. Wow. Okay. Well, should we see what it shows? One thing that we could do, spawn planning. I'm actually going to add in. I'm going to say, no, I don't want to do a case right here. I'm going to say debug finished computation. And let's see, we'll skip all the compute stuff right here. But the reason I'm doing this is it's going to make it really easy to say. Actually, I'm going to write it the other way. Just return computation. Oops, comma right there. No, we might as well write it like this. But essentially, I want this right here. And we're going to say, oh gosh, what is it? Computation dot, notice how we have to make sure that it actually exists. I only want to do that work inside of here. But hopefully you see what I'm doing right here, where basically we're always going to call this, but we're going to make it really easy to skip the actual debugging. We don't care about it. So if it's not finished, then throw. If we get past it, then we know that our finished computation exists. So we can say X and Y. Yeah. Wait, is that right? Oh, yeah. So notice how we get rid of our context at this point. We just have X, Y cost. Computation. Cool. So yeah, that's it. So that should work. And now if we run back over to here, let this refresh hopefully. I don't see it doing anything. Oh, look at that. I got it backwards while I was doing my refactor. So let's run back over to here. And look at that. We have chosen our spawn point. Now I would... So what I'm thinking about at this point is we don't have a lot of feedback to see the computation. So I would basically like to have it freeze on a specific frame of it. So what I'm gonna do, I'm just gonna kind of hack this temporarily. Compute best candidate. Yeah, let's do that right here. So I'm just gonna say return computation. So we're passing it through, right? But this way, we're going to end up in an infinite loop where we're always in this state, and we're just going to do it over and over and over again. And so we'll get to see what that looks like. I saved. Yeah, I saved. Reset the exploration. Distances. Sweet. Okay, so now notice how like every single tick, we're computing the best candidate. Notice how we've got all these numbers. Sorry, I'll zoom in. Hopefully you can see that fine. But each of these yellow numbers is a candidate, so it's far enough away from walls that it is a valid location. Notice how this is a 29. These are all 29s, so I guess any of these are valid, really. Um, and I'm cool with that. I think like, yeah, that's kind of interesting actually. That like, oh, actually, I have an idea here. Like, wait, my bot might be more advanced than yours, but your structure is massively better than mine and very inspirational. Oh, thanks so much. I really appreciate that. Yeah, that's a big thing for me. Like, I think, yeah, like my bot isn't very advanced at this point. Like, I'm okay at early game. I haven't got a lot of the other stuff figured out yet. But I am trying to do this in like as methodical of a way as I can. So that's cool. Yeah, mind if I ask what you've done to get a strong grasp on data structure? So some of the things that I have done, let's see. So I do have a college degree in computer science. That was really helpful. My advice to folks is like, if they're interested in studying software and like working in software, I say maybe a college degree is right for you. You know, maybe a computer science type degree is right for you, but maybe it's not. One of the reasons why I feel like it was right for me, and I'm going to switch over to here. So one of the reasons why I feel like it was right for me was because I do really love the data structures and the algorithms. I feel like it's a way to be creative in a way. But maybe the biggest reason is actually programming languages themselves. So as you might have already been able to tell, I really love languages and studying languages. So, you know, on this channel, I will compare JavaScript to TypeScript to Rust to Java. Like, you'll hear me talk about all these different languages because I really love that. There's so much that we can learn. Like, let's say that you know, your 9 to 5 is, you know, working in JavaScript, but you're doing something on the side in some totally different language. That's exposing you to concepts that you can go back and use at work. Like, even if you're not using that same language, you can still use it. So, and that relates to data structures because, for example, when we're talking about Rust traits, we're thinking about how we write our software in a way that's like anti-fragile. We're writing it in a way that that like uses that concept. So I guess like paying attention to those concepts, even if they're not in the language we use every day, is really valuable. I think the other thing I would say is, let's see, about data structures. There's some things that I do at work that really relate to data structures that might be helpful to think about as well. So let's see. I work with some technologies at work that have to do with messaging. Let me explain what I mean by that. So I'm going to switch over to Excalidraw once again. By the way, after 1 month, you should sell your entire Excalidraw mockup as an NFT. Thank you. I love that. That's very silly, but it's also like high praise, I guess. By the way, it sounds like you're familiar with NFTs. There is a strong community of like generative artists that are doing NFTs, and we do like we actually have done generative art on this channel occasionally. So if you're interested in that, like tune in. Specifically, I've got a couple designs that are like generated laser cut designs or pen plotter designs that go on the front cover of a synthesizer module. So, you know, in the back here, I've got my modular synthesizer, and I've actually designed one module, and I'm working on a couple others. But I want the faceplates for that to actually be like custom designed by me in a way that like every single panel, like if 10 people buy it from me, then like all 10 of them are going to have a slightly different panel design. So really excited about the idea of like applying generative art to machining that like goes into some other thing. So that's that. Okay, anyway, sorry. Sidetrack on NFTs. The thing I wanted to talk about was messaging. So let's see. I work in SaaS, software as a service. I work at a very cool company called Podium. I'm gonna wrap it really quick here. If y'all are looking for a job, DM me. We are hiring right now for a few different teams. Yeah, so very cool company. It's all about communication tools for local businesses. And so I work with a few different teams. I'm what you call a software architect. And so we work in SaaS, right? And so we're thinking about the front end of the code and the back end of the code. The front end is like the JavaScript that the user is clicking on, and then the back end is like, right, they're working on the APIs and interacting with the databases and all that good stuff. But think about this for a second. And by the way, this is all to try to answer the question of like, how can we get stronger at data structures? Sorry, that's what the question was. So let's say that we're working on the back end of an app, and as your app grows, you're actually not going to have just one server, but you'll have a whole bunch of servers. And even Screeps is this way, if I understand correctly. Like their architecture includes like the script processors and some ingress type stuff for like login and like authorization, authentication. There's like a stats API. Like there's a few different boxes that all do different dedicated things. So let's say that you are, the client, right? And the user interacts with the client. The client makes a request to some server. I'm going to call this like app one to make a change, right? But in order to do that, app one also has to talk to app two, or maybe it's like app one needs to update some detail about the user, and then kind of downstream from that, it's got to update some detail in app two. And maybe in order to illustrate that, I'll kind of put that here, where it's like kind of it's a side effect, right? What's the pay? It depends. DM me. It depends on the team and the role. So app one needs to perform some kind of a like side effect to like let app two know. But let's say that like something crazy happened, and for a split second, app two has actually crashed. So this connection has broken. Well, now whatever work was supposed to get done doesn't get done. App one is not going to do app one did its thing, but app two certainly didn't do its thing, and that might turn into a huge problem. Now, you could get really tricky where like app one is going to do retry logic. It's like make an API request to app two. If it fails, like wait half a second and then try again, and then like try a third time, and then eventually give up and blow up. You can think about recoverable errors versus unrecoverable errors, where like maybe it's fine, like if this fails, maybe it's okay. Or maybe it's a real deal breaker and like this has to succeed or whatever. It like the user doesn't necessarily need to wait for it, but like eventually it needs to be there. We can't just drop that data or drop that event. So this is where data structures start to come into play. There's a concept called a message broker. So message broker, and I'm trying to kind of jankily illustrate it here, so bear with me. A message broker essentially has this idea of a queue. So when app one does some work, it's going to drop a message on this queue, and then whenever app two has time, let's actually reverse the arrow to make that clear. Whoops. Then it will read from the queue. And so the contents of this queue data structure is like a bunch of JSON that's like, hey, user A did action B or whatever. And so whenever app two gets around to it, it can read this message off of the queue. And what this lets us do is, suppose that app two has crashed, right? That's totally fine, because app one can write some data onto this queue, and it's now saved away. Like we're good to go, right? App 1 can go on its merry way and let the user know that they can keep using the app. And then eventually app 2 is going to start back up again, right? And app 2 is like, hey, message queue, do you have any work for me to do? And sure enough, there is data on the queue. And so it can just pick up where it left off. And like, that might be 1 second later, it might be 1 hour later, it might be like 3 days later, who knows? But what we've done is we've created resiliency in the system, and we've done it through data structures. And so my job specifically deals with a lot of this type of work where we basically start with, we start with an architecture where this directly calls this, and we realize that it's not scaling. Like we have too many customers, we have too many requests like hitting our servers all at once, that like we can't keep doing this. And so we move from that model with request response, we move to this queue-based model. If you want to learn more about this, a couple of really good technologies for doing this are RabbitMQ and Apache Kafka. There's also AWS SQS. I don't use that one at work though. I use these two. My very favorite one is Apache Kafka. I think it's amazing. I had been programming for like a decade by the time I came across Apache Kafka, and I genuinely feel like it changed like everything about how I program and how I think about programming. It was like a genuine paradigm shift in my life, like professionally and in terms of my career and in terms of like code. So I don't know if you needed that much of a soapbox about this in particular, but like I am like deeply, deeply passionate about this idea of like messaging systems. And when you use messaging systems, it forces you to think about data in new ways. Cool. Okay, thank you for coming to my TED Talk on that in particular. Cool. All right, back to our regularly scheduled program. Let's see, we were just about to reset. Oh yeah. So we wanted to see the computation freeze. What was it? We wanted to see it freeze during selecting the best candidate. Oh, I guess we did that, right? So that's there. As a matter of fact, it's pretty easy to do the same thing up here with calculating distances, and that might be kind of cool. Return computation. So now if I say, let's see, reset exploration once again. Yeah, here are my distances. So yeah, if you look on the Screeps Plus wiki, this probably looks familiar, where each of the walls is 0, and then from there you've got like 1, 2, 3, 4, 5, and it's each of these little islands of like 5+ that we care about. So oh, and notice by the way that like our CPU is under control. Actually, it's a little high. I think it amortizes out, especially once we turn off the debugging. We should be able to do this in just one tick, and we're not going to like blow everything up. So I can run this on shard 3 and like do this work. It'd be fine. Okay, so let's go back over to here. But this is awesome. I think we're at a point where we can reset. It'll decide. Yeah, look at that. It's computed the best candidate. There it is. And like we're happy with it, which means we should be able to go and apply this to explored rooms, which is what we've been trying to do this whole session. And now we're there. When are you planning on entering shard 3? Let's see. I'm not on shard 3 yet. I'm actually on shard 0 today. It's like totally not doing me any good to be on shard 0. I'm actually I'm crammed into a corner of a block. And there's some like really big overmind bot close to me. I don't know. Maybe I could like try to conquer the Overmind bot. I don't really want to like take that on right now though. I feel like at this step, I'm more interested in like proving out this model that we've got so far for expansion. And so, yeah, I'm thinking like a different shard. I've got some space on shard 2 if you want to move in nearby. Hey, that could be fun. We could like do some collab. Yeah. We could write a little bit of code to be allies so that like if we explore into each other's rooms, we don't like immediately kill each other. Yeah, that'd be fun if you're interested. I don't see your bot on shard 0. I should be on shard 0, right? Don't go trying to exploit my website, please. But like, here's this little like visualization I spun up. So let's see. I'm on shard 0, room this. There we go. So yeah, you should be able to find me there. You can see fun little stats about how it's doing. But yeah, like at this point, it's like not really doing anything for me, and so I'm totally fine even to like just respawn, and not wait to like get killed or anything. But like, yeah, I could respawn in shard 2 or in shard 3. Actually, Dollar Akshay, like, where are you currently spawned? Because I think that's a good option too if you're interested in doing a collab as well. Yeah, we can see. Oh yeah, and Marvin TMB, let me know where your addresses are on shard 0, or like kind of where you had in mind for me to move in. We can look at doing that. Let's see. We did that. Shard 3, West 23, South 42. Okay, sweet. Let's see. Hope you don't mind. I'm gonna just copy this into here. I will copy it kind of out of there we go, and then TMB, and let's see if I can create this thing. Oh, shard 2, space to expand east. Oh, I see. Yeah, it's just a, yeah. Okay, sweet. Here, let me give you a room location. Cool. Awesome, yeah. Okay. Cool. So we got some cool options here. I want to jump back up to here really quick. Hope that's cool if I'll, like, I want to look at both of them and try to figure out, like, what's going to be a good, like, story for the stream, if that makes sense. Like, I want to find some things that'll, like, help me illustrate this and, like, help me grow the bot in a way that's meaningful. So, yeah, I'll do a little bit of homework and maybe, yeah, I'll try to, like, DM you if I'm, like, ready to spawn in and set some of that stuff up. But, yeah, super appreciate it. That'd be really fun to team up. So let's see. We've got, oh yeah. DM me on Discord. Awesome. Yeah, we'll do. Is your DM, or sorry, is your username on Discord also Dollar Akshay? Yeah, okay, cool. Yeah, I'll hit you up. Okay, the final thing that I wanted to do is we should be able to see this whole algorithm run for all of the rooms. So what I'm going to do, let's reset the exploration one more time. And now I'm going to say room.first dot create explorer. By the way, I should rename Explorer to Scout, because like everybody on the stream is like, you gotta use Scouts. And I'm like, oh, well, I do. They're just like named the wrong thing, or named like something else. Oh, whoops. I want to say game that spawns that spawn one dot create explorer. Okay. So that is doing its thing. Looks like he's chosen this room down here first. You'll notice that my pathfinding logic is real janky, so that does still need to get fixed. In the meanwhile, we're gonna like do this silly snake kind of dance. I can't remember who said it, but they were like, "Yeah, isn't Screeps all about approximation and then polishing?" Yeah, this is one of those areas. Okay, so here we are in this room. Oh shoot. I should have done this in advance. It's already left. Okay, let's run back up to here. I did not think this through. It should be coming like right into here. Hurry and load this up. Come on. Okay, here we go. Huh. I don't think it's actually processing at all, because we should be seeing compute context. Like that should run even just on the first tick. So let's see, exploration. No. Roll.explored. We get his memory. Update facts about the room too. Yeah. Update room exploration. So this should have happened. What are we doing wrong here? Room exploration. Maybe have it move to the center of the room so you can test easier. Yeah, we could do that. Let's see. It's in room. If it's not in the room, then go to the room. Let's just hack this really quick. Is on room border. I'm trying to think if there's like a really easy way to tweak this. What is this? Oh, I think the types were actually incorrect earlier when I wrote this like years ago. So I need to go back and fix this in particular. You'll notice all these like janky TS ignores. Let's see. Let's maybe... if I remember, go to room actually says... We need to just simplify this. Just temporarily. If we are exploring... Let's do this. So we'll say creep.move to, right? And then we'll create a new room position that is 2525 in that room name. Which is what? Target room? Yeah, okay. So that way we're just gonna end up like sitting in the first room that we get to. Oh wow, now we're calling it. Okay, so here's our Intrepid Explorer. If we come over into here, rooms, we didn't record this room. So that's interesting. I don't know what's going on there. This probably is an issue where we need to fully reset the exploration. Yeah, I think we're in a bad state. So let's actually do that. I'm gonna blow up this creep, and then we're gonna say room.first reset exploration. Thank you, Marvin, for calling out that we should just make that a command. That has paid off. Okay, and this is for sure running on the homeroom. Okay, so now let's say game spawns, spawn one, create explorer. That'll spawn really fast. And it's gonna pick a direction. Which one is it choosing? I guess it's this one. Come on. I'm puzzled why our local server is lagging so bad. Maybe it's actually the UI thread that's like CPU bound rather than the network being a problem. We're in here. Okay, here we go. It's entered the room. And now at this point, click refresh. Open this up, exploration. Look at that, there's still only one room. So I have definitely broken something about this. It should be the room itself. Role.explored. There's something wrong in here. Initialize room. When it comes to memory efficiency, I think storing exploration data in the room.memory is more efficient. Oh, are you talking about like as opposed to deeply nesting it? Because it is in the memory for that room. I guess we're only reaching into it when we have visibility into the room, and so room is actually a object. Let's see. Yeah, I feel like initialize room is not actually happening. I guess we could verify that really quick. So if we just say rooms, open this up. Yeah, we have a whole bunch of rooms. Oh, but when I reset exploration, and I'm gonna go ahead and do it again, this should like clear out. Not clearing out. Role explored. Oh, hold on. I wonder if we missed something in here. Oh, we are not actually doing this work. Shoot. Okay. Alright, this is my bad. You'll notice that this is like copy pasted over from here. This is a directive that runs for the room. But yeah, we went and spliced it in, and then we like extracted that. So like this is, yeah, this copy paste madness has like kind of gone through a couple of iterations, and this totally just bit us. So yeah, yikes. Okay, so let's reset exploration again. Oh, okay, hey. Okay, so this is cool. I think what this is telling us is it probably couldn't find a candidate, actually. So let's make it stop freaking out. I'm just gonna wait. Where's my cursor? There. I'm gonna make it return early. Okay, so now it's gonna stop exploding anyway. No? Oh yeah, we're okay now. Okay, so I should be able to inspect the exploration at this point. So let's refresh this. And actually, this is a chance to speed this up just a little bit. Should I even... Yeah, dot exploration. So if we open that up, 2 rooms. Here's the home room. We should have already done all the work for it. So yeah, that's there. That looks great. West 8, North 2. So that's this room. Yep. Plan spawn. So we've computed the distances. Here's the controller, right? 36, 26. Yeah. Sources. I assume those are right. I don't really care. Bounding box. Cool. So you've got numbers for those. Distances. Let's double check that the distances are correct. So we'll do that same trick. Maybe that's not actually building though. We have to comment out all of the things. Okay, so let's double check. Yeah, so we built, and now we reset exploration. Reset exploration. Okay. Oh, yeah. Can everybody see the problem? We didn't find any... like, there are no green numbers because we didn't find any places that are 5 or more spaces away from a wall. So, in other words, there are no candidates. Like, there are no solutions according to our current algorithm. So that's cool. That makes sense. So, I think there are a few different things that we need to do now that we know this. I'm going to bring this back. So let's see. The first place where this should blow up is probably right here, right? So candidates is going to be an array of length 0. Yeah, let's see. Hey man, how long have you been playing? Yeah, since about 7 or 7:15. So I guess we're coming up on 3 hours. Yeah, thanks for joining. Good to have you with us. We're not going to go too much longer. I've got to go to bed at some point here. I'm in Mountain Time, so we're coming up on like 10 p.m. Let's see. Okay, so it's possible that there are no candidates, which means there cannot be a best candidate. So it's probably like this could throw. or some of those other like, best candidate.x could also throw. So, oh, how long have you been playing since you started? Like, how long have I been playing Screeps total? Let's see. So I started like 3 years ago, and I played for a while. I put in several hours. Kind of put the game away for a long time and came back to it a couple months ago. And so what I'm doing this time is I'm coming back and I'm interested in like fully automating my bot. It was really pretty heavily manual to begin with. And I didn't get too far. Like, I don't know, I would say I was like okay at mid game, if you want to call it that. Like, I could comfortably use storage, room storage. But I didn't have like automated expansion or any of that. Like, I did expand to 2 or 3 other rooms, but it was on a very manual basis, like kind of hard coding commands for creeps to go out and claim and like take over rooms. So yeah, that's kind of where I'm at. And so I'm trying to take a very like disciplined approach. Dollar Akshay jokes that I should sell this diagram as an NFT. If you're interested, you can buy it. Just kidding. But like we on this channel, we do a lot of like kind of whiteboard type stuff. And so going down the bot arena type goal. I actually haven't done bot arena yet. I need to get a copy and give it a try. But yeah, for now I'm focusing on world and kind of learning what I can from that. Cool. Oh, so Q and Marvin, do you both do bot arena? Actually, Marvin, I think you shared a YouTube video of you playing. Cool, super cool. Yeah, we're planning to compete. That's awesome. Okay, so let's see. There might not be any candidates. So I want a way to express that. I think that's different from skip. So skip is something that I would use for like hallway type rooms where like it doesn't even apply anywhere. Like there's no controller. Whereas I want to have a totally different status that's like no, or maybe like could not solve. Because the implication here is that like maybe if I fine tune my parameters, or if I like shrink down a city block, or like have kind of a fallback that doesn't even involve city blocks at all, then like eventually I could actually come back to this and I can solve this. So yeah, I'm gonna do it this way. I think that'll work well. So now could not solve is the same thing, but like we'll just return the computation and we'll throw this up here. Yes. And so what this means, where did that go? There it is. We want to say if candidates.length is 0, then return status could not solve. Oh, by the way, this gives me a chance to get back on my soapbox about data structures. So you remember my whole spiel about messaging, right? So messaging comes into play when you're thinking about adding a new status. So the reason that I chose to do it this way, rather than to do it this way, it has to do with the idea of migrating an API, or moving from one version of an API to a newer version of an API. And I basically felt like the API that I used to have with these 5 statuses, they weren't able to express a new concept. And so I needed to add this new data type in order to be able to do that in a way that I can like come back to and boot up and like get more value from later. there are implications of that. Notice how when I added this, and here, let me comment out this code, right? As soon as I added this, TypeScript put a little squiggly here. Function lacks ending return statement, and return type does not include undefined. So this is a symptom that basically says this switch statement is not exhaustive. So there's a possibility that I might end up right here. Like TypeScript is actually smart enough to figure that out. And so as soon as I add this back, the squiggly goes away because it's like, oh, cool, this is an exhaustive search or an exhaustive branching. This, by the way, is like yet another reason why like type systems are the best. Yeah, go type systems. But there's an implication here that has to do with messaging systems as well, which is like, let's say that app1 introduces a brand new data type. Like all of a sudden it might start writing data onto the queue that looks like this. Well, that could be a problem for app2 because app2 suddenly picks that up and like has never seen that kind of message before. And so it's going to crash. Cube, you are one of those people. Oh man. Oh, specifically to TypeScript? Yeah. Oh, it gets worse than that, Q. Listen, I've already got the Rust docs open. Like, I was on my soapbox about Rust and traits, and like Rust traits are like a language, like first class thing that's better than monkey patching in JavaScript protocols or prototypes. Like, yeah. You missed my previous soapbox from tonight with everybody else, but like I'm a major programming language enthusiast. So if you're into that, give me a sub. If you're not into that, this might not be the right stream for you. But hopefully there's something here that will pique your interest. I'm very much about like let's do it methodically and let's like lean into the tools to help us. I like the chaos of JS, to be honest. Cool. I can respect that. Okay. So we added this, could not solve. So now, let's see. I need to remove the hack. Where did I put that? Right here. Okay, so we've computed distances. Now we try to compute candidates. We didn't find any. And so now, if we shrink down all the things ever, cancel changes, cancel changes, cancel changes. We open this up, then we should see that this room could not solve. Perfect, it worked. Okay, this is awesome. So now what we can do, okay. So here's what I'm thinking about next. Go to room. I want to go to role explorer. So we've got this logic here, and I want to like travel to the next room. I want to like comment this back out again. Yeah, I guess we can begin. I'm going to say like convenient hack to, let's see, to stay in the current room. And we're not going to do that. Okay, so we're going to go back to the normal code. The Explorer will very quickly realize that it has already been in this room. It's going to take the next assignment. And it should head over to that room just to the east of our homeroom. So we will try to beat it there. This crazy thing loads. Here we go. And let's see. We know that this is getting called at the right times now, so I'm cool with removing that comment. Okay. And I'm really hoping that this has a solution. But who knows? We might find out that this currently doesn't have a solution either. In which case, I think we might go sooner rather than later to the... Yo, I think it just did it. We might need to come up with like a fallback for these like really big city blocks. Okay, so let's hit refresh. We found another room. West 7, North 3, yes. Plan spawn, could not solve. Okay, we found another one that we couldn't solve. We did get all the way through it, so that is great. Okay, that's interesting. City blocks. Do you do you play Factorio? Yes, I do. Big fan of Factorio. It's super fun. Are you a Factorio person as well? Yeah, actually, I only just recently learned about what's their name? I can't remember. Nilaus, I think. About 500 hours. Amazing. I think like there's got to be a very large overlap between like the Screeps community and the Factorio community. Yeah, for real. That's great. The Venn diagram is probably like, if you play Screeps, you also play Factorio. If you play Factorio, you may or may not play Screeps, but like maybe it's the gateway drug to Screeps. You can see this is doing its thing. Maybe come back into here. Yeah, good times. Heard a lot about Factorio, never played it. Yeah, it's really fun. It's a big sandbox game all about factory automation. It will take away years from your life, but it's a blast. Okay, so this is West 2, North 2. Yeah, plan spawn. Could not solve. Gosh. Okay, so yeah, I mean like all three of our rooms that we found so far could not solve. We know the algorithm still works. Like I think we at least have one data point that it does work based on the homeroom, because it was able to find a candidate. So I think what this means, Factorio is basically a game about coding, but you're constantly injected with heroin. Love that. Let's see. We just found another one. Look, okay. West 7, North 4. So if we just go up 2 from here, we actually found a spawn location. So this is very promising. So if we go up one more, and I think that debugging is still on, so it should tell us where the candidate is. Is it going to tell us? Oh, do you have to have room visibility in order to render room visuals? I'll bet you do. Because that would explain... Yes, okay. Yeah, that would explain why we don't actually see that. Oh, wait, you know what it really is? Oh, you can directly create new room visual object in a new room. Oh, actually, okay, so we could create room visuals. What we're actually doing is we're not executing this code. So we don't have, it is true that we don't have room visibility, which means that this code for the room role is not being executed. Yeah, which means that all the other stuff internally, which like renders the room visuals, aren't getting called. But what we could do, 25, 26. Where is that? 25, 26. Right here. This is our spawn location. So it looks like it's, I don't know, it looks like it's a little closer to that left source, but like, yeah, it's like more or less in the center of an equilateral triangle. So I definitely believe this as like a valid location. So this is awesome. Like, I feel very happy about this. I'll bet if we refresh this, we found maybe one more, hopefully. Yeah, we found a couple more. So this one, could not solve. This one, could not solve. Okay, cool. I feel very happy that we found this one. Like that feels like a big win. Awesome. I feel like this is a commit. So let's go ahead and do that. So let's see. Yeah, we added the command to reset exploration. I got a couple random things that we don't want to check in. Oh, we don't want the directive reset exploration, so I'm going to leave that out. And then the exploration module is now going to do all this work. Yes. Yes. By the way, what I'm doing right now is git add -- patch. If you use git, but you're maybe less comfortable doing it over the command line, probably because you're not totally sure like what is being committed, this is a really good way to do it. I've been using git over the command line for a long time, but this is still like my preferred way to use it. Yes, that's good. Wait, hold on. What is? Oh yeah. That's for temporary data structures when we're like looking at the whole graph. Let's see. This looks good. Yep. Yeah, we now update those facts, so we can get rid of this to do. I would like that debug. So we'll skip these once again. Not these. And then we want to add this module. Yeah, that all looks right. Let's see, so we're gonna say implement logic to plan spawn locations. Perfect. Okay. Well, friends, I think we are just about up, but before I go, I actually want to show you something absolutely unrelated to Screeps. I'll inject these in from time to time. So you might have remembered from I think it was last time that I talked about this cool little project. So this is my very cheap, very DIY Stream Deck. So I can actually use this to control my OBS setup. So I can like switch, between a couple different scenes this way. I'm not going to push the blue one because that one does that one goes to my like BRB screen. But anyway, that's cool. That's some of the electronic work that I do. But I want to show you another one that I'm like right in the middle of because on Thursday I'm going to do some machining for it. So let me grab that. And this one looks a lot more legit. So what you're looking at here, this is called the Universal Traveler. And this is a box that transforms MIDI signals. So here is this 5-pin MIDI connector. Maybe you've seen this before. This controls synthesizers. So, we've got these synths in the back. Turns out that there are a lot of retro synths from the 80s that they have kind of non-standard MIDI implementations. And so if you want to control them from your modern software, you have to do weird stuff in order to kind of translate it into what that synth expects. So this box, and it's all, in kind of skeleton form on a breadboard right now, but this piece of hardware and software, what it does is it takes an input signal from USB, right? So it's a MIDI signal, but it's happening over USB from, producer software, a digital audio workstation. And it goes through this board right here. This is called a Teensy 4.1. So it's kind of like an Arduino, if you've heard of an Arduino. It's also kind of like a Raspberry Pi Pico, if you're familiar with those. And what it does is it does all that translation work so that it goes from your fancy, newfangled, modern MIDI signals to your gross, old, retro MIDI signals that your old synths will understand. And then there's this toggle button that will let you switch between presets so that if you've got a whole studio full of retro synths, you can toggle between them and send data to different ones. So this is actually a project that I have collabed with Eric Robertson from Pleasant Pictures Music Studio on. He runs a studio in Provo, Utah, and he's got this entire room of vintage synths from the 70s and 80s, and it's amazing. It's this playground for nerds. Lots of wires and knobs and stuff, and very cool retro sounds. But he really needs something like this in order to get the most value out of his synths. So we're teaming up on this together, and we're now at the stage where we can actually build an enclosure for this. So what that means is we're going to take this. We're not going to build what's called a printed circuit board or a PCB, where it's a custom designed circuit board for this. But what we're going to do instead is we're going to put it on a proto-perf board, which is sort of like a permanent breadboard. It's like breadboard but with solder. And then what we're going to do is we're going to create a faceplate for it that will look kind of like this. So this is a rack mount shelf that's going to go into his studio equipment, and you'll notice that there are these big screws on either side. The idea is you put a faceplate over the front of this, and then you can have studio equipment exposed right on the front. So we'll just about drop that on top of the box. That would have been very bad. So what we're going to do is we've got this plastic acrylic right here, and I've designed a faceplate in FreeCAD. So if you're familiar with CAD software to do machining, I've designed the faceplate, and then we're gonna go to a makerspace in Provo called ProLab Studio, and we're gonna carve out that faceplate with a laser cutter so that everything fits in perfectly. Mount it to the shelf, get it into a studio. So yeah, should be really cool. This project has been through a couple of iterations, and we're really excited about getting it into a state where it's not necessarily like a finished product, right? But it's it'll be to a state where he can keep it in his studio, plugged in all the time, and it's going to be safe. It's not going to gather dust from the exposed breadboard, and he'll be able to have that right above his computer screen. And so whenever he needs to switch to a different synth, he can just press that button, and everything is all wired up so that he can start making his synth wave right away. So it's a major workflow improvement, lets him interact with his synths in ways that actually are not possible through some of those. Turns out the 80s were this era where people were adding a knob for every single thing is barbaric. We're gonna hide all of our functions behind these menus, these beautiful menus that you have to press a billion buttons in order to control. So this is gonna let him have a setup where he can super easily just reach in to every one of his synths and make changes and automate stuff and create cool music. So anyway, very excited about that. I'm showing you kind of the guts of it on the stream. Yeah, sounds good. I hope you can show the finished project on stream. Yeah, I will try to. So once that's all cut out and it's a little bit more assembled, I'll show you what that looks like. And I think when it's in a little bit more of a finished okay state, I'll turn it into a YouTube video. So that way we can make it a little more polished. You can hear the results. Like, I don't know if y'all are into synthwave, but like the retro, like big synths and drums that are like really in these days. Eric actually specializes in that. He's done it before it was cool. He's been playing synthwave for like 10 years professionally, and like records for commercials and for other people, like other bands. So like he's awesome at it. Like, I'm pumped to like create a video out of this because like it's gonna be really good. So yeah, super excited about that. Thanks for listening to my spiel about this like unrelated project. But yeah, anyway, I'm Andrew. This is Code Gets Creative. Thanks so much everybody for tuning in. Really appreciate you. And we'll be back really soon. Stay creative.